For every 1 gallon of yellow paint, we need 1/3 of a gallon of red paint. True or false? Oh, I got a nice mixture. Let's talk about it. So, if I multiply 1 times 3, do I get 3? If I multiply 1/3 times 3, do I get 1? Is this true? Yes. Every 1 gallon of red paint requires 3 gallons of yellow paint. Okay, Brown, give me 5. We have a lot to learn today, hands down. I need you at 100% so we can get all the way through the lesson, okay? Good. For every 1 gallon of red paint, we need 3 gallons of yellow paint. 1 gallon of red, 3 gallons of yellow. Is this true? Uh-huh. Go ahead. There's 1 gallon of red paint in a 4-gallon mix of orange paint. Is this a 4-gallon mix? Yeah? We've got 1, 2, 3, 4 gallons. How many of them are red? 1. Is this true or false? True. Mm-hmm. You're at level 0. I'll wait. There are 2 gallons of yellow paint in an 8-gallon mix of orange paint. Now let's pause. Up here and right here, this mix of orange paint, what does that mean? Is that like a whole different color? No. What are we doing, Aranza? It's all of them together. We're mixing red and yellow to make orange. So when they say a mix of orange paint, they're just saying the total, all of it mixed together, right? So we're talking about a part-to-part or part-to-whole ratio in the last statement. Juanita.
The last statement we're talking about a part-to-part.
We have a part, which is yellow, to the mix.
Oh, a part-to-whole.
Yeah, this one's part-to-whole. So we have to change our original ratio to part-to-whole so we can compare them. What part are we comparing to the whole, Hillary? What part are we comparing to the whole?
2 gallons of yellow.
Yellow. Yellow. So in our original ratio, how many gallons of yellow did we have? 3. And how many total gallons did we have? Alice? 4. So 3 out of 4 total were yellow. And I can see that if I want to look here and double check myself. 3 yellow out of 4 total. Now this ratio says if we have 2 yellow out of 8 total, and we're trying to figure out if that's true. 4 times what is 8? 2. We have to do the same thing here, right? Is 3 times 2, 2? No. Is this true or false?
False.
Exactly. Okay, so let's look at our ratio 1 to 3 because we're using the same ratio as in exercise 1. Red to yellow, 1 to 3. We need to complete our table. In our third column, we have a new column. It says relationship. We're showing the relationship between red paint and yellow paint in the third column. So, what goes here? 1. Because the relationship is 1 times 3 equals 3, which is written here. 3, which is our yellow paint, is 1, which is our red, times 3. So that's the relationship. We're multiplying by 3. If I carry that all the way down my table, what goes here?
6.
What goes here?
3.
What goes here?
4.
And here?
15.
What's the relationship between 2 and 6? 6 is 6 equals, there we go. 12 equals 4 times 3. 15 equals 5 times 3. Let's talk about exercise 3. Does this look like a lot? It looks like a lot to me. It's like a paragraph, right? Are we scared of big, long problems? Absolutely not. We know how to pick out the information we need. Okay? Yes. You can go sharpen it. Go ahead. Okay. Jorge he's mixing paint again, okay? He must have bought a new house. This time he's going to mix red paint and blue paint. So he's going to have an orange room, and now he's going to have a purple room. The color of purple he wants to make combines red paint and blue paint in the ratio 4 to 1. So 4 to 1 is our ratio. And is that blue to red or red to blue?
Red to blue.
Red to blue. So I have to label it. I don't want to get my values backwards. If he can only purchase paint in 1-gallon containers, let's complete the ratio table that shows all the possible combinations of blue and red for no more than 25 total gallons of purple paint. Okay? What can I write in the first row? Amaya? 1 where? In what? In the blue part? Yep. They try to trick you, right? Red to blue is the ratio you were given. The table's written as blue to red. So you just have to write the numbers where they go. Pay attention to the labels. What's the relationship between 1 and 4? Alice? 4 is 1 times 4. Goes here.
8.
Here?
2. 3, 4, 5.
And for each of these gallons of blue paint, I'm going to multiply by
4.
to figure out what? The gallons of red paint. So here,
8, 12, 16, 20.
20, right? We're not counting by 8s, we're counting by 4s. So 8 is 2 times 4. 12 is 3 times 4. Yeah, you can say it either way, that's fine. 16 is 4 times 4. And 20 is 5 times 4. Good. Okay, here's the new part. We're going to write an equation that will let Jorge calculate the amount of red paint he will need for any given amount of blue paint. Just a moment. Okay. We need to calculate red paint. I want to know how much red paint does Jorge need. So we write our equation by starting with red paint. Red paint equals how much, right? That's what we want to know. What do I do to my amount of blue paint to find the amount of red paint, Kai? I multiply it by 4. So red paint equals 4 times blue paint. When I write an equation, I do not need to write the multiplication sign. I have a number and a variable, not a number and another number. So I can write red paint equals 4B. That means 4 times blue paint. Yes, some of you are familiar with this.
Yeah.
If you're writing a variable right next to a number, that just means you multiply. So there's our first equation from this table. Let's look at the next page, page 63. Yes, ma'am?
I have a question.
Uh-huh.
If you do that to like a division problem, will it work like that or no? Like using the variable.
Yes.
Hello?
Yeah, let's do it. This time, I want to write an equation, but this time I want to find out how much blue paint does Jorge need. What do I do to the value of, or to the quantity of red paint to find the quantity of blue paint? Hillary?
You divide it by 4?
Yes. I take the quantity of red paint and I divide it by 4. That tells me the quantity of blue paint. Another way I can write this is 1/4 times the amount of red paint. Okay? R divided by 4 is the same as 1/4 times R. Yes?
Why are you writing it as a fraction?
Why am I writing it as a fraction? Because any number divided by 4 is the same thing as that number times 1/4. Because what's the first step when you multiply by a fraction? Top times the top. R times 1 is R. Over the bottom times the bottom. 4 times 1 is 4. It's the same thing. Okay. Kai?
So basically all you're doing is just multiplying the amount of y times 1?
Yes.
Okay.
Because it's the numerator of the fraction. Exactly. Nathaniel, do you see the lanyard?
Well, did you take it off of there?
No? Put it back, didn't I?
No,
Yeah.
yeah.
Gabriel took it. Okay. If Jorge has 24 gallons of red paint, how much blue paint will he have to use to create the purple that he wants? So I have we made 2 equations. I have red equals 4 times blue, and I have blue equals 1/4 of red. Which variable do I start with to answer this question? What do I want to find out? I want to find out how much, Amaya? Huh? I want to find out how much of what? Blue. How much blue paint will he have to have? So blue equals some amount we don't know that we're going to find out. So whatever you're looking for, that's what you start with, okay? The amount of blue paint is equal to, well, our equation that looks like that is blue equals 1/4 of red. So if we have 24 gallons of red, then blue equals what? Unique, what can I do? If blue equals 1/4 times red, and we have 24 gallons of red, then blue equals 1/4 of, yeah, and what's red in this problem? Say it loud. 24. We're taking this value, 24 gallons of red, and we're just plugging it in where we put the R in the equation, because the R is just a placeholder. The R just means some amount of red paint. So when they give you an amount for red paint, you can plug it in and find blue paint. Right? So work it out and let me know what is 1/4 times 24 gallons. Raise your hand when you have it. 1/4 times 24. Coral, what did you get?
6.
Yes, she got 6 because first you got 24/4, right? And that's the same as 6. 6 what? Gallons of red. Blue. Thank you. Paint. This question asked for blue, so 6 gallons of blue. Now, Jorge has 24 gallons of blue paint. And he wants to know how much red paint he'll have to use.
Yes.
Which equation should I use? Equation 1 or equation 2? Show me with your fingers. Show me on your fingers. I'll have like 5%. I want to know how much red paint he needs. So I use equation 1. Because equation 1 starts with red paint, and that's what I want. Red paint is equal to how much? Red paint is equal to 4 times the amount of blue. So for this problem, red paint is equal to 4 times what? 24. Work it out, you have 10 seconds. Okay. And what did you get? Lucas. Lucas is in my homeroom. Isaac Lopez.
96.
96. That's exactly right. 96 gallons of...
Red paint.
Now we're talking about red paint. 96 gallons of red paint. Okay, second part of this question. It looks like a doozy too, right? It's big. It's all right. We know how to pick out what we need. Question? Okay. Sure. Loud and proud, please.
Okay. Using the same relationship of red to blue from above, create a table that models the relationship of 3 colors, blue, red, and purple total paint. Let B represent the number of gallons of blue paint. Let R represent the number of gallons of red paint. Let T represent the total gallons of purple paint. Then write an equation that models the relationship of the blue paint and the total paint and answer the questions.
Nice. So this time, we need to fill out our table using the relationship that we used in part A. So what was the ratio in part A of red to blue? Say it. 4 to 1. Good. Pay attention to the order because order matters, and tell me what to write in my first row. Isaac Soseda.
Blue 1, red 4, purple 5.
Yes. The total amount of paint is our purple paint because it's the red and blue mixed together. So the total is 5. Now, just a moment. Let's fill out the rest of our table. If I have 2 gallons of blue, I need
8.
nice 8 gallons of red. How do you know that? Okay. Alice, how do you know that 8 goes here? Yes, because the relationship between blue and red is that we multiply by 4. Red is 4 times blue. So if I have 3 gallons of blue, I have, if I have 4 gallons of blue, I have, and if I have 5 gallons of blue, I have, 20 gallons of red. How much total, when I point to it, you're going to tell me? Yes, 10.
15, 20, 25.
Now we need to write an equation that models the relationship between blue paint and total paint. Are we worried about red paint for this problem?
No.
No. I don't want to look at it. I'm not worried about it. I don't want to get confused, right? Juanita? Okay, so we're writing an equation. The equation is comparing blue paint and total paint. What's the ratio of blue paint to total paint, Amaya? 1 to 5. Create an equation that represents the relationship of blue paint to total paint. Go ahead, I'll give you 1 minute. Okay, let's talk about it. Your ratio is 1 to 5. That's blue to total. Now there's two different equations I can write, right? I can find out how much blue given a certain total, or I can find out how much total given a certain amount of blue. Which one do you want to do, Kai? How much total if I have some amount of blue? So the total would equal... Huh? Well, here's what we did. Up here we wrote the ratio as blue to total, but in our equation, the order is the opposite. So, the total is 4. Where are you getting 4? If we wrote it the other way, total to blue, it would be 5 to 1, right? Bless me. Okay. So the total is what? 5 times blue. Good. 5 times blue. Because if I drew the relationship on my table, if I didn't have all this mess in the middle, because we don't need red, I would write that 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15, and so on. So the total number of paint is always 5 times the amount of blue paint. So an equation we can write is that the total is 5 times blue. What is the ratio of total paint to blue paint? Did we find that up here? Yes. What is the total to blue ratio? Say it. Good. Did it ask for the ratio or the value of the ratio? The value. So we can write it as a fraction. Can I write this fraction as a whole number? Yes. What's our value? 5. Now, good. Here's the equation. Here's the value. Turn and talk with your partner and explain how the value is related to the equation, how the value of the ratio is related to the equation. Go ahead. Okay, bring it back in 3, 2, and nice. Okay, who has a great explanation? What is the relationship between the value of the ratio and the equation? Amaya, what you got? Just a second. Okay. So we need to understand the value. We need to understand the value, how it's related to the equation. What do you see? What do you see? Juanita.
That the value is 5 and what you're multiplying is 5.
The value as long as we write it in the same order as we do in our equation, tells us what to multiply our variable by. The value determines what we multiply by the variable. Are we always, when we write an equation, are we always finding a total? Are we? Are we always finding a total when we write an equation? No, you can write a part-to-part ratio, or you can have a part-to-part ratio and write an equation for it. Variable, the variable, sorry. It says the value determines what we multiply by the variable. Okay. Let's move on to exercise 4. Exercise 4 says, during a particular U.S. Air Force training exercise, the ratio of the number of men to the number of women was 6:1. So you always write what you know. Right? Yeah, I'm not happy about it either. The ratio of the number of men to women was 6:1. Now, use the table provided below to create at least 2 equations that model the relationship between the number of men and the number of women participating in this training. So, what can I write in the first row of my table? Arlene. 1 here? Yes. Smart. She didn't get tricked. They're written in an opposite order than they were given to us, but she paid attention to the label and she knows there was 1 woman for every 6 men. What's the relationship? Kai? 1 times 6. Good. 1 times 6 is 6. So 2 times 6 is
12.
3 times 6 is
18.
4 times 6 is 5 times 6 is perfect. It's okay.
I thought I said 30. Yeah, I thought I said it wrong.
Okay, 2 equations. We're going to write part-to-part equations. We're not worried about a total right now. We're worried about the part that were men and the part that were women. So if I want to write an equation that tells me how many men there were if there were a certain number of women, what does that look like? What does that equation look like? Say it. What do you think?
I don't know. What's it?
So Kai says 1/6 times the amount of women. Now, here's why we're not there yet. This is why. Because I'm writing in the same order as the ratio, I can use the value of this ratio as the number I multiply my variable by. So what's the value of this ratio? Aisha? The value of 6:1, which is just, what's the whole number? Yeah, 6. So if I want to find the number of women, or I'm sorry, the number of men, I can multiply what by the number of women? Hillary?
6.
6. 6 times the number of women. Now, Kai, if I want to know how many women, what do I do to the quantity of men to find the number of women? Yes. You said it before. Yes, 1/6 of the number of men, because the order of my equation now is women equals some amount of men. So women to men is 1:6. I can write that value as 1/6. As long as my equation is in the same order, that's my value that I multiply by the variable. There's our 2 equations. Now we can answer the question. The question says, if 200 women participated in the training exercise, use one of your equations to calculate the number of men who participated. So here's equation 1, here's equation 2. Show me on your fingers, which equation should I use to solve this problem? Don't be looking around, just put your fingers up. What do you think? Hands down. Isaac, why number 2?
Because it turns it into a fraction.
What?
Oh, no, it uses women first and then.
Okay, because the problem mentions women first. Nathaniel, what do you think?
Because we need to find out the number of men that participated if 200 women participated.
Yes, we need to find out the number of men. So which equation are we using?
Equation number 1.
Equation number 1. The number of men is equal to 6 times the number of women. So the number of men is equal to 6 times what? In this problem, 200. So how many men are there?
1,200 women.
1,200 men. Let's look at exercise 5. I want to take a risk. A risk.
What's that?
I'm going to explain. For exercise 5, I'm going to read it to you, and then you're going to work on it with your partner. Now, I will do a quick sweep of the room, okay? I'll let you know if you're on the right track, or I'll circle what you are a little off on so you can fix it, okay? I'm not going to stick around for long. I want to get to everybody. Okay, Malia's on a road trip. During the first 5 minutes of her trip, she sees 18 cars and 6 trucks. Assuming this ratio of cars to trucks remains the same or constant over the duration of the trip, complete the ratio table using this comparison. Let T represent the number of trucks and C represent the number of cars. Before we do anything, we need to write what we know. What is the ratio? Amaya? 18 to 6. And is that trucks to cars, cars to trucks?
Cars to trucks.
Oh, I wrote a C. Why did I do that? Okay. 18 to 6, and that's cars to trucks. Now, you have everything you need to complete this table, and this table will help you complete the questions. Go ahead and add a level 1. Work with your partner. Okay. When I point to it, you tell me what goes there.
Okay.
3, 9, 6, 36, 29.
Give yourself some snaps. What is the value of the ratio of cars to trucks? So cars to trucks. What's the ratio of cars to trucks? Isaac? 18 to 6. What is the value? We have to write this as a fraction. What's the fraction? Can we write it as a whole number?
Yes.
What is it?
3.
Now we need to write an equation to model the relationship. As long as we keep our equation in the same order, cars first and then trucks, what can I put here? 3. At the end of the trip, Malia had counted 1,254 trucks. How many cars did she see? Before you tell me the answer, tell me what to do, Arlene. The number of cars equals 3 times the number of trucks, and in this problem we have 1,254 trucks. So how many cars did she see? Amanda?
3,762.
3,762 cars. Okay, let's look at exercise 6. Pause. Track me. Once again, as you work on exercise 6 with your partner, I'm going to do a quick sweep, let you know where you're at. I'll come by a few times. Go ahead. If he walked 1 minute, how many minutes did he run? 5. So the relationship is 1 times 5. 2 times 5 is 10. 4 times 5 is 20. 8 times 5 is 10 times 5 is 50. So, what is the value of the ratio of the number of minutes walking to the number of minutes running? So we're looking for walking to running. What's the ratio, Coral?
You
What?
messed up.
What did I miss? I did?
50 times 5.
No, 10 times 5 is 50.
Oh, yeah.
Yeah, that's okay. Hey, it's the end of the day. I understand. So, walking to running, the ratio is, Amanda?
1/5.
1 to 5. Good. 1 to 5. I'll wait. I gotta write that as a value because that's what the question asked for. Unique? 1/5. This is my value. Okay? As long as I write an equation where the minutes walking are what I want to know, so I write that first, I can use my value to multiply by the second variable. There's my equation. Good job. The only thing I noticed that I want you to really, really stay on top of. Eyes on me. Okay. Pay attention to the order of your ratio. That's the hardest part of dealing with ratios. You cannot write them backwards. You get a totally different situation. If I walk for 1 minute, I gotta run for 5 minutes. I don't want to run for 5 minutes. I don't want to walk for 5 minutes and run for 1 minute. That's a different training schedule, right? I change the whole situation if I switch those numbers. Adam. Exactly. You can also write it as walking equals running divided by 5. These are the same thing. This is easier to see because we just plug in the value. Now, roll leaders. Eyes on me.